Drifting of continents and plate tectonics. In order to understand the drifting of continents, let us first begin with Wegener's continental drift theory. Well, Professor Alfred Wegener was a German scholar who put forward his theory of drifting of continents in 1912 and revised it in 1924. Well, Alfred Wegener noticed the coastline of several continents looked like they fit together like the puzzle pieces. He was very impressed by the jigsaw fit of the eastern and western coastlines of the Atlantic Ocean. He observed that the bulge of Brazil would fit in the Gulf of Guinea, and the North American coastline would closely fit in the coast of Scandinavia and Western Europe. Similarly, the bulge of Ethiopia on the east coast of Africa fits in the coastline of Western India and Pakistan. Australia can easily fit itself in the Bay of Bengal. Such outstanding similarities in the coastlines, especially that of the Atlantic Ocean, were called jigsaw fit by Wegener. He believed that around 200 million years ago, all the continents were joined together in one large supercontinent that they called Pangaea, which is Greek for all the earth. Pangaea was surrounded by a vast ocean called Panthalassa. The northern part of Pangaea comprised of North America, Europe, and Asia, and was known as Laurasia. Similarly, the southern parts of Pangaea comprised of South America, Africa, peninsular India, Australia, and Antarctica, and was known as Gondwana land. Both Laurasia and Gondwana land were separated by a narrow and shallow sea known as Tethys Sea. Over the course of millions of years, they broke apart into the continents we know today as a process he called the continental drift. Wegener collected several evidences in support of his continental drift theory. Some of the outstanding evidences are, firstly, fossils. Wegener tried to explain the drifting of continents on the basis of distribution of fossils. For example, fossils of the plant Glossopteris and animal Mesosaurus have been found in the Carboniferous rocks of India, Australia, South Africa, South America, Antarctica, etc. These are widely separated areas, and such a distribution can only be explained by accepting the concept of continental drift. Next, geological matching. There are gold deposits within river alluvium in the Ghana coast of Africa, but there are no source rocks in that region. However, across 5,000 km wide Atlantic Ocean, there are gold-bearing veins in Belém, Brazil, South America, but there are no gold deposits within alluvium in the adjacent coastal belt. Occurrence of such stunning similarities in distant lands gives importance to the continental drift theory. This shows that Africa and South America were parts of Pangaea and drifted apart at a later stage. This is explained by placing Africa and South America together. Although this theory explained quite a bit about the origin of the Earth, scientists at that time weren't impressed and initially dismissed his ideas. Thus, it has been criticized on several accounts. First criticism: flow in jigsaw fit. Jigsaw fit is not as complete as claimed by Wegener. If we bring South America and Africa close to each other, their coasts leave a gap of about 15 degrees. Next, talking about the time of drift, several objections have been raised regarding the time of drift. Critics have asked, What kept Pangaea intact till the hour of drifting struck? Why did the process not become operator until that date? Why it could not happen at a later time? Such questions constitute a serious criticism of Wegener's presentation of his case. But today, Wegener's concepts are the basis of the modern-day plate tectonic theory. So what exactly is the plate tectonic? Well, plate tectonic states that the Earth's outer mechanical layer, the lithosphere, is divided into large continent-sized plates that are constantly moving. They move pretty slowly at 1 to 2 inches per year. These lithospheric plates of the world have been divided into two types: the major plates and the minor plates. Talking about the major plates, these includes African plate, American plate, Antarctica plate, Australian plate, Eurasian plate, and the Pacific plate. Talking about the minor plates, these includes the Arabian plate, Bismarck plate, Caribbean plate, and the Philippines plate. Now let's see how it all works. According to the plate tectonic theory, these massive lithospheric plates are all moving in different ways, and how they interact with each other can have a huge impact on the Earth. Where these plates meet are called boundaries. Well, talking about the plates, there are three types of plate boundaries. Firstly, convergent boundaries. Secondly, divergent boundaries. And thirdly, transform margin or transform boundaries. Well, talking about the convergent boundaries, these boundaries occur where two plates are moving towards each other. Talking about the transform boundaries, they occur when two plates are sliding past one another. Thirdly, talking about the divergent boundaries, they occur when two plates are moving away from each other. Well, in case of convergent boundaries, when two plates collide, a couple of things can happen. The denser oceanic plate is forced below the lighter continental plate. This creates a subduction zone. The overrun plate is subdued over the mantle, and part of the plate is melted and forms magma. The magma comes over towards the surface, forming volcano or volcanic mountain along the continental edge. An example of this is the Ring of Fire, which is an active ring of volcano that encircles the Pacific Ocean. Well, the other thing that can happen is that the rock about the boundary lifts up due to collision, and it gets folded and forms the fold mountains, such as the Himalayas and the Alps. Although the movement of convergent boundary is gradual, as pressure underground builds, the impact above the ground can be violent. Fast movement can lead to earthquake. These are not just the only boundaries that can result in earthquake. Well, the earthquakes can occur at transform boundaries where the earth plates are sliding past each other in opposite direction, which creates cracks or faults on the earth crust. As the plates try to move, they rub against one another, resulting in the building up of pressure. If the plates are stuck for a long period of time, the pressure will continue to build at the fault line until eventually releases, resulting in earthquake. San Andreas Fault is the largest transform boundaries. Next, talking about the divergent boundaries. Like mentioned before, they occur when plates are moving away from each other. Either the space between the two plates widen, becomes a large crack or rift, or if the space between the two plates under the ocean, where the crust is thinner, the upwelling of the molten lava takes place and fills the space. This is called the sea floor spreading. The mid-Atlantic ridge is an example where sea floor spreading occurs. So, in review, the plate tectonic theory is based on concepts proposed by Alfred Wegener. The lithosphere is divided into continent-sized plates that are constantly moving. The continents were once part of a supercontinent called Pangaea. Lithospheric plates move 1 to 2 inches per year. Boundaries are where plates meet. 3 types of plate tectonic boundaries are there: convergent, transform, and the divergent plate boundaries. Volcanoes and mountains form as a result of convergent plate boundaries colliding. Earthquakes and tsunamis occur at convergent and transform boundaries. Fissures, cracks, and rifts in the surface occur at divergent boundaries. Lastly, sea floor spreading occurs at divergent boundaries on the ocean floor.